let's continue with factoring these. So some things that I noticed, I'm missing my middle term, it's gone. The other thing that I noticed, that 625 is a perfect number. It's 25 times 25. Wanted to make one of them positive and one of them negative in order for me to get the negative. And that this would have to be, that there's a 1 here. 1's a perfect number, 1 and 1. And then an x squared and an x squared. So I got perfect numbers on either side. I'm missing the middle term. So, and there's a difference of squares. So now if I do my diagonals, I've got a negative 25x squared and a positive 25x squared, which if I add those, get me 0, which is why my middle term is gone. So I just have a 1x squared plus 25 and a 1x squared minus 25. And I do not need to write the 1's. These become so easy that after a while you don't even need to do that. You can see, okay, 81 and 16, both are perfect numbers. Actually, I'll just do it for this one, just because it's got a couple things. 9 and 9, x4 is going to be x2 and x2. 16 is 4 and 4. y4 is y2, and y2, I have to make one of them negative. So my diagonals are negative 36 x squared y squared and positive 36 x squared y squared, which get me a 0 x squared y squared, and 0 times anything is just gone, and my middle term is indeed gone. So that's all there is to it. You have a 9 x squared plus 4y squared and a 9x squared minus 4y squared. So these should become very, very easy. I mean, this one you should immediately be able to do. You're like, okay, this is going to be 25. So 25 and 25, that's going to be 9. 9 and 9. And then I need my x's and y's. At x4, well, that'll be an x squared and an x squared. y4, that'll be a y squared and a y squared. One of them needs to be positive, one of them needs to be negative. So it should become very, very fast like that. Now, what ends up happening, we're done that's difference of squares. You could get something called perfect squares or just squares. You'll notice that in the previous question we had an x plus 3 and an x minus 3. And that got us a difference of squares. But what if they were both plus? So plus and plus. And in which case we write that like this. So what ends up happening for these ones? Well, honestly, nothing different happens. So it wants us to multiply, so we'll just multiply and we'll see what we get. X times x is an x squared. Then we get a 3x, and another 3x, and then a 9. So we get x squared plus 6x plus 9. That's multiplying. Okay, well, I don't really know what to make of that right now, but let's just keep going here. 2 times 2 is going to be a 4x squared plus 6x plus 6x plus 9. So normally, in the difference of squares, these ones would cancel out. Here, they kind of just add up. They just double. 6 and 6 is 12. Carry down the 9. Carry down the 4x squared. Okay. Well, I don't know what to make of that right now. Again, this is all grade 9 stuff. We're just multiplying things. 2 times 2 is going to be a 4x squared minus 6x plus 9. So minus 6 and minus 6 is going to be a minus 12. There's a 4x squared and a plus 9 that gets carried down. So what do we notice about these? Nothing. I don't notice much. One thing I do notice is that the first one is a perfect number and the last one's a perfect number. So when I go to factor these, maybe I'll, instead of trying to figure out, okay, do I do 4 and 1 and 2 and 2? It's like, oh, that's perfect, 2 and 2. 9's perfect, 3 and 3. So that might be it. This is, again, 4 is perfect, 9 is perfect. 1 is perfect, 9 is perfect. So they are all perfect squares, but really it makes absolutely no difference when we factor these things. This question, if you look back, we probably have already done this one. Nothing's changed. X is going to be x and x to get an x squared. I know this is 25. I'm going to try 5 and 5. And this was a 1, so 1's a perfect number, 1 and 1. 1 has a perfect number, 5 and 5. And then we need to get a diagonals here. So I think they both have to be negative. So this diagonal is going to be a negative 5x. This diagonal is going to be a negative 5x for a total of negative 10x. That is indeed what I have in the middle. So I can just write this as x minus 5 times x minus 5. Now you could leave it like that. They are identical, so you could write x minus 5 all squared. Maybe that's the only difference, is that if you get two things that match up, you can write it this simpler way. Okay, moving on to the next one here. 4, what I'm going to do, I notice that 4 is perfect and 25 is perfect, so I'm just going to do the halves. 4, sorry, not the halves, the square roots. Half the square root of 4 is 2, and 2. Square root of 25 is 5, and 5. And this diagonal would be 10, and this diagonal would be 10. 10 plus 10 is 20, and I need negative 20. So I'm going to make both of these negative. So then this diagonal is a negative 10x. This diagonal is a negative 10x for a total of negative 20x. That is my middle term. So I'm going to have 2x minus 5 and 2x minus 5, which I'm going to write as 2x minus 5 all squared. And the last one here. Okay, I notice 49 is a perfect number, so square root that is 7 and 7. I have to do an x and an x. 36, perfect number, 6 and a 6. And this is 42, and this is 42. And that's what I have. 42 and 42 is 84, and I have an 84. Perfect. So I have 7x plus 6, and another 7x plus 6, so I'll just square it. And there you have it. So really, what has changed in all of these? Absolutely nothing. We do all of these the same. I make this little grid. For the ones up top here that we just did, you make up the grid and you make sure that your diagonals get you 0 because the middle one's missing. Here, for these ones, all of these ones down here, you make the little grid and you do it the exact same way and make sure it equals the center, which in this case was negative 10, negative 20, positive 84. So really nothing's changed. I will leave this zoomed out though. I want you just to remember that I'm not going to ask you questions like question 3, and I'm not going to ask you questions that look like example 1. Those are grade 9 questions just asking us to multiply, and you were supposed to maybe notice a couple things. But what we're asking you to do is factor. So example 2 and example 4. So just keep all of that in mind. Don't worry about your multiplying stuff.